All right, so this is a lesson from Friday, graphing polynomial functions. You really need the information from the day before with behavior and degree with leading coefficients. If you haven't watched that, go back. But if you have, let's keep moving. First, when we graph a polynomial, we really start by using the zeros. And we know that zeros are where we have our x-intercept, so that's where the graph crosses the x-axis. We're going to start by plotting those points first. That's going to make our graph. A polynomial with degree n, so degree n can mean any degree, so 5, 6, 12, whatever n is, has that many real zeros. So if I have degree 5, then it can have at most 5 real zeros. Now notice it says at most because that means 5 is the most, and then it could have less than that as well. An even degree polynomial has an even number of zeros, and odd has an odd number. And then we use our factoring skills to be able to come up with those zeros. Once we factor, we have what are called the linear factors. And so once we have everything out in factored form, we take each factor, and remember we set it equal to 0 so that we can solve and actually know what the zeros are. So when we factor today, keep in mind we now know GCF, we know X method, we know difference of squares, sum and difference of cubes, we know factor by grouping. All of that could come up here. So as I look at our first example, we're going to have to factor out a GCF of X, which leaves me X squared minus 2X minus 15. Once we look at that, this inner part in the parentheses can factor by X method. So -2 when I add, -15 when I multiply, and our A value was 1. So then this gives me -5 and +3. And so my factored form is X minus 5, and X plus 3. And that's what our function f of x is now. Our zeros come from setting each factor equal to 0, which, don't forget, your first factor was that GCF of x. So taking that and setting it equal to 0 means that my first 0 would be x equals 0. The second one comes from our second factor of x minus 5. And if we solve that, that means x equals +5. And then our last one would be x equals, plus 3 equals 0, which means x equals -3. My brain was trying to jump straight to the answer. Now, that is a skill we know how to do, but now we're going to take that a step further, because those zeros and this factored form gives us one more piece of information we'll need for graphing, and that is called multiplicity. Now, the multiplicity of each zero is equal to the number of times you see that factor occurring in the factored form. So the multiplicity is essentially the power of the factor. So this factor x has a power of 1, which we would say multiplicity of 1. This x minus 5 also has a power of 1, so we would say it has a multiplicity of 1. Same thing on this one. So now as I look at the second example, I've already factored. Let's talk about the zeros, and then we'll add in that multiplicity. So for the first factor, we have an x. That means our first 0 is x equals 0. The power on the x is a 1, which means this would have a multiplicity of 1. The x plus 2 equals 0 would give me a 0 of -2, but again, the power on this factor is a 1, so I have multiplicity 1. The last factor would be x minus 3, which means my last 0 is +3, but it's having a power of 2, which makes my multiplicity 2, because remember, power 2 means that there are two factors that are identical. Now here's what multiplicity tells us about the graph. The multiplicity tells me how the graph behaves on the x-axis. So if my multiplicity is odd, then my graph crosses through the x-axis at the x-intercept, or at the 0. If my multiplicity is even, then we're going to refer to today as it bounces. meaning it's going to touch the x-axis and then turn. Kind of like when we described a double root in our parabolas. All right, so let's use everything we've talked about and go with this example 3. First, it's going to have a GCF of x, which gives me x squared minus 6x plus 9. Then we're going to factor that inside, adds to negative 6, multiplies to 9. Notice in this case, they're identical, negative 3 and negative 3. So I can write this as x minus 3 squared, since both factors match and they're the same. Now, my 0 here would be 0. My 0 for the second factor would be positive 3. The power here is 1, so multiplicity 1. The power here is 2, multiplicity 2. And odd means that we cross, and even multiplicity means that we bounce. Now let's take a look at this graph. When x equals 0, the graph itself is crossing through the x-axis. When my 0 is positive 3, the graph is bouncing. In other words, it touches and then bounces back up, or touch and turn, and so there's that bounce that we're talking about. Now the rest of the graph itself comes from what we learned in our prior lesson. These end behaviors come from the degree and your leading coefficient. So in this case, we know the degree is 3, and because that's odd, we can either go fall, rise, or rise, fall. But the leading coefficient being a positive number means that we should have fall and then rise. So fall, rise. So when we sketch our graphs in a little while, we know this starts with fall, which means we go up, we cross, we turn, come to the other 0. This one is a bounce, so touch and turn, and then it ends at rise on that side. All right, so let's try to do a whole graph by ourselves. All right, so first we're going to identify our zeros. So in this case, our 0 would be negative 4 first. And its multiplicity would be 2, which means that this guy's going to bounce because my multiplicity is even. Be careful with this second one. Set it equal to 0. This gives me negative 1/2. Multiplicity 1, because the power on this is a 1. That means this graph is going to cross. On the next one, the 0 would be positive 4. Multiplicity 3 means it's odd, and it's going to cross. I'm going to put a little star on this one. When the power is an odd number bigger than 1, the cross squiggles a little bit more when you cross through the x-axis. Now, we're not going to be real picky about that, but it'll just help me when I do a graph here. All right, so now I know what should be happening on the x-axis, so I'm going to go over to the x-axis and go ahead and just label it. So here's my x-axis. Remember to put these in the correct places. They don't always come out in order, so make sure you're putting them numerically in the right spot. So negative 4 is here, and I'm going to plot that dot. I'm also going to mark underneath here that we said that the graph is going to bounce here. Then I'm going to go to negative 1/2, which is here, and we said here it should cross. And then the last one is at positive 4, and there's a 0 there. And in this one we said it's going to cross, but it's going to cross kind of squiggly, okay? The last thing you need to be able to do this graph correctly is your end behavior. So your end behavior comes from knowing the degree and the leading coefficient. Now, when this is factored out and you have not been given the polynomial in standard form, you can either multiply it all together to get your degree, or there's a shortcut to this. Your multiplicity is going to add up to what your degree is. So in this case, 1, 2, 3, 4, 5, 6, this tells me that the degree of this polynomial is 6, which is even. So it's either going to point up on left and right, or it's going to point down on left and right. Now the leading coefficient comes from all of these leading coefficients multiplied together. So 1x, 2x, 1x. A positive times a positive times a positive, that would make a positive leading coefficient. So that means that our graph should rise on the left and rise on the right, which means on the left, as x goes to negative infinity, our y values go to positive infinity, and the same thing on the right. Now using that, we can finish drawing our sketch. And I'll change colors to do that. All right, so I know we rise, so I know that this guy comes from up here. And then we have to come to the first 0, touch and turn or bounce. Then we come through this one and we cross. Now we got to turn and come through this one, but we're going to squiggle a little bit when we cross. And then there's our rough sketch of our polynomial. And notice that it says rough sketch. It's not very accurate in how the minimums and maximums are behaving, but it shows you what the graph is doing in general. All right. Question 5, I did not factor for you, so we're going to have to do it all ourselves. So first, we will factor. So in this case, I have a GCF of negative 2x squared. That's going to give me a positive x squared minus 2x minus 8. Then my x method, I'm going to look for something that adds to negative 2, multiplies to negative 8, and my leading inside is a 1. All right, so negative 4, positive 2, so negative 2x squared, x minus 4x plus 2 is my factored form. Now I can go ahead and put in my zeros. For this first one, if I were to set that equal to 0, and divide by negative 2 and square root both sides, I still get 0. However, the power on this is a 2, which makes this multiplicity 2. That means there's going to be a bounce here. And I'm going to erase this to give myself some more room. The next factor is x minus 4, which means positive 4 with a multiplicity of 1. We've got a cross. And then negative 2 multiplicity 1, we have a cross. And because they're 1s, it's a straight cross through, not a squiggle. All right. The last thing we need to know is what is the end behavior going to do, and it's always easier to look at the polynomial, not the factored form. So the polynomial is showing me that the degree is 4 and the leading coefficient is negative. Now also let's use that trick again. 2 plus 1 plus 1 is 4, so it does match that the degree equals 4. All right, so if my degree is even and my leading coefficient is negative, that means we're going to have fall, fall. So on the left, the y values go to negative infinity, and on the right, the y values also go to negative infinity. All right, so let's draw ourselves a graph. Starting x-axis first and plotting your zeros. So my first 0 is on 0. And we said here we would have a little bounce. My next 0 is at positive 4. And here we said it's a normal cross. Then we go to negative 2. And here we said it's also a normal cross through the graph. Now let's actually plot the graph using the end behavior. So it has to fall on this side. So fall. So we cross, turn, touch and bounce, turn, cross. So fall on the right, fall on the left. There's my rough sketch of my polynomial. All right, so the last example, we have already provided you a graph, and now I'm going to ask you for all that information plus some of the things that you did in yesterday's assignment. All right, so as I look at this one, let's look at end behavior first. The end behavior on the left side as we go to negative infinity is pointing to positive infinity. As we go to the right hand side, as x approaches positive infinity, our y values are going to negative infinity. All right, the next thing we want to do is we want to identify zeros. First 0 I have is negative 2. And because we are crossing through the x-axis, we're going to say the multiplicity is 1 because of the cross. All right, the next one is at negative 1. In this case, the graph itself does cross, but it's kind of squiggly when it crosses, so we're going to say this one is multiplicity 3. Or it could be 5, it could be anything bigger than 1. We'll just keep it easy and say 3. The next 0 here is 1. And so this one does just a normal straight cross through, which make multiplicity 1. And then our last 0 is 2, and it is a bounce. So multiplicity here we'll say 2. All right, great. Now, based on the multiplicities, 1 plus 3 plus 1, now we're at 5, 6, 7, that's odd. Because we go rise and then fall, that tells me my leading coefficient needs to be negative. The domain is all real numbers. Your range is all real numbers. Now remember, relative maximums and relative minimums are your highs and lows. And remember, they come from turning points. So anywhere there is a high and low or a turning point, that's either a minimum or a maximum. So the minimums and maximums are these little highs and lows. All right, so let's start with maximums. The first maximum or peak that I see is sitting up here. The second maximum that I see or peak is sitting here. Remember, these are y values, so my relative max would be 10 and 0. My minimums are the lows, the bottoms of the peaks. So here is one, and then here is another. So my relative minimums would be -7 and -4. Now, I did not circle -1, 0 because that is not a relative min or max. That's just a cross through the graph, and it curves a little bit. And so here, when I do my increasing and decreasing intervals, remember, it only is where your turning points are. So on this one, let's be real careful. As we are increasing would be from here, and it doesn't stop increasing, it goes all the way to here. So turning point to turning point. Then we have another increase here, turning point to turning point. So as we do this one, the increasing interval, remember our x values, would be from -1.5 to 0.5 and never include turning points. Union, the other one was at +1.5 to 2. Now, as we do the decreasing, again, it's turning point to turning point when your graph is coming down from left to right. So here's a decrease, and you go through that cross, because that's not a turning point, you're just crossing through the x-axis, and then there is one more decrease there. All right, so my decreasing intervals would be from -infinity to -1.5. Never include them, so parentheses. 0.5 to +1.5. And then union from 2 to +infinity, because we're referring to the x moving to the right forever. All right, go ahead and start your practice.